this PC. Yeah. All right. Okay, I guess we are good to go. Sorry for the inconvenience. Hello everyone. My name is Deepak Akkil. I'm from University of Tampere in Finland, and the work I'm going to present here today is about gaze augmentation in egocentric video improves awareness of intention. Continuing the same line that all my co-speakers spoke about. So video communication devices are increasingly used to share activities and experiences. So currently, people use video communication devices, for example, to give a tour of a flat or repair machines collaboratively. Also, head-mounted cameras are growing in popularity. Cameras integrated into smart glasses, they are known to support remote collaborative tasks that require mobility or use of hands. If you keep that information aside and also look at human gaze plays a very important role in face-to-face interactions. For example, eye contact and gaze conveys attention. For sometimes you could even point with gaze in face-to-face interactions. So taking inspiration from that, a lot of previous research has looked into how gaze could be used in remote collaborative settings. For example, when you're collaborating using a shared display to remote participants, showing the gaze of the remote participant could be used. For example, Brennan and others found that in a visual search task, it's more faster than simply collaborating by voice. And Nadar and others found that for spatial referencing tasks, conveying gaze of the remote participant is more efficient than speech. And Quadfort and others found that it conveys interest, reduce ambiguity in communication, and aid topic switching. So there has been multiple benefits of gaze awareness in a shared display-based collaboration settings. So it, of course, makes sense to apply the same in a scenario where it's based on egocentric video-based collaboration. For example, the video from your head-mounted camera with the additional gaze overlay on it. For example, something like this. So here, the red dot indicates where exactly the person is looking at, and the camera view is from the head-mounted camera. But then there's one marked difference between a desktop-based, shared display-based collaboration and head-mounted display-based, head-mounted camera-based setup, because the camera is already on the head and it already conveys the visual attention to an extent. So would having this precise indication of gaze add any benefit in a remote collaborative setting? So what we did was we went back to the literature to understand where it has been previously studied. So it's not a completely new idea. The same concept of gaze-augmented egocentric or first-person video was studied as early as in 2003 by Fusel and others. They compared this setup with a stationary camera-based setup and also a co-located collaboration-based setup, but then they could not find any measurable benefit of having the additional gaze overlay in the head-mounted video. They ran into a lot of trouble with accuracy of tracking and slippage of gaze tracker, which again led to tracking issues and a lot of technical challenges. And they concluded that maybe gaze tracking capable head-mounted devices may not yet be robust enough for actual field application. Gaze tracking research in the last decade has been improving considerably. And there is a growing interest to go from a controlled lab setting to a mobile everyday scenario in gaze tracking research. Even though it's still not perfect, it has considerably improved in the last decade. So we feel that the technical challenges faced by Fusel and others may have been resolved to a large extent in the current state of the technology. And after 13 years, we wanted to revisit this area one more time. So we did a early pilot study to understand where having this additional gaze overlay could be useful. And based on the early pilot study, we hypothesized 3 potential benefits of having this additional gaze overlay. For example, for spatial pointing, when your hands are occupied, you could simply look at something to point at that object to the remote partner. It could also be used to enable grounding in communication. For example, your remote collaborator could know that, okay, your partner understood what you said because he's now looking at it. And also there's this additional benefit of intention prediction. For example, with gaze, when you combine it with context, that you could, to an extent, understand what the person is going to do. So we wanted to work on one of these potential benefits. The focus was to understand if having this gaze overlay in the video would add any benefit, and we wanted to focus on one of these three, and we picked intention prediction for our study. So if we look at natural gaze behavior, there are two kinds of fundamental fixations that exist. There are based on the functionality of these fixations. There are guiding fixations which are relevant to the current subtask. For example, if you are about to pick a coffee cup, you would look at it just before picking it up. It's relevant to the current subtask. If you are pointing at something, you would look at it when you are pointing at it. But then there is also these other kind of fixations which are called look-ahead fixations. The amazing thing about this look-ahead fixations is that it's not related to the current subtask. It's actually related to a future subtask. And the whole reason for having these look-ahead fixations is that your brain can plan the upcoming motor actions better. For example, in this video, the person is taking coffee already, and then he looks at the milk dispenser when the coffee is being poured. So the idea is that you can plan your motor actions when with this visual information. Okay, so what is known that this look-ahead fixations, the existence of it is known. It is a ubiquitous aspect of human everyday gaze behavior that is known. And these fixations sometimes occur 4 to 8 seconds before an upcoming action. All that is well studied in the literature that exists. But what is not available is that people viewing an egocentric video with the gaze overlay can pick up these subtle gaze cues and combine it with contextual information to understand an upcoming action or intention, the task-related intention of the person. And understanding that was the focus of our study. So we hypothesized that gaze overlay in the video improves the observer's awareness of task-related intention. In our study, we did not have an actual collaborative setup. There were two reasons for that. One was that we wanted to reduce the cognitive load and time pressure that is associated with a real-world collaborative setting. And the second was that our intention was to focus on if having the gaze overlay would add any benefit. With gaze awareness, there could be cost and benefits with gaze awareness, right? With the red dot moving around. So we only wanted to focus on the benefit part of it to understand that, okay, it actually works in this scenario, and then we could, in future, study a real-world collaborative setting. So our study was conducted in 2 phases. In the phase 1, we recorded egocentric videos of actors in a driving scenario, driving through a 4-way intersection in a car simulator. Why we picked up driving scenario in this study? Well, driving is a common everyday activity, and if the smart glasses become a commonplace, these could also be used while driving. And there is previous literature that suggests that if there is technology that allows collaboration, driving, there could be scenarios where there could be remote guidance scenarios or remote navigation scenario where someone is remotely helping you go to a location. And another important reason for selecting the driving situation was that the gaze behavior while driving is extensively studied, and the existence of look-ahead fixations and how in a real-world driving scenario your eye moves is well documented. So that was another reason for selecting driving as a scenario in our study. And in the second phase of our study, we had participants view this driving videos, and their task was to predict which way the driver is going to turn at a 4-way uncontrolled intersection. In the first phase, we had 2 actors who were 27 years old, male and female. They had both had driving license and number of years of driving experience, it was safe to assume that they had established pattern of driving and gaze behavior, which was representative of a real-world driving scenario. We used the city car driving simulator and an Ergonair decoupless binocular 60 Hertz gaze tracker to record the eye movement. Our actors were told to drive like they would normally do. They did not know the real purpose of the study until the whole recording was done. The reason being that we thought knowing that would probably bias their gaze behavior, they might do exaggerated eye movement that would enable easier prediction. All right, so we recorded 15 videos of this car driver passing through an uncontrolled four-way intersection. So they had 3 turn possibilities. They could either turn left, turn right, or go straight. So once we had this video, in the second phase, we invited 12 participants to take part in our study. We followed a within-subject design with one independent variable, which was the presence of gaze point indicator. Each participant viewed 1 minute of free driving video so that they would get used to the actor and how his gaze behaves in a naturalistic setting. And in the actual videos, the car approach, there was up to 10 seconds to the approach of the intersection. And when at that point, before any clues were available through the steering wheel motion, the screen paused, the whole screen turned white, and on-screen questionnaire asked which way the driver is going to turn and how confident you are with your prediction. We could see one of the videos that we had. Up to 6 seconds till the intersection, and as soon as it was close to the intersection, the video paused, and on-screen questionnaire asked which direction the driver is going to take, left, right, or straight, and how confident you are with the prediction, which was a Likert scale of 1 to 7, 7 being very confident. And once they submitted, the video continued so that they could learn which way the driver is going to take. But then for the presentation, I'll show the same video again with the gaze augmentation so that you can compare. And here the red dot indicates the gaze point of the driver. And again, the video paused, and the person could answer the question and how confident they were with the prediction. And as soon as it was submitted, the video continued, and they saw what was the correct direction that the driver proceeded in. And if you look at the results here, when there was gaze point available, the participants were more accurate with their prediction of turn direction. And the median value was 12 out of 15, and without gaze point, it was 9 out of 15, which a completely random prediction would have meant 5 correct answers because they had three choices. So that also means that in the no gaze condition, they relied on other clues. For example, the approach speed of the vehicle. If the speed was fast enough, that probably meant that they were planning to go straight. And also the position of the car in the lane. For example, one of our actor positioned the car to the left when he was about to take the right so that it could safely navigate the turn, and so on. There were also subtle clues available from the head direction as seen through the egocentric view. Consistent with this finding, the confidence in prediction was also considerably larger when the gaze was available, and both these differences were significant. We were also interested in how the experience of the participants in terms of driving influenced their use of the gaze overlay. In the background questionnaire, we asked the participant how often they drove a car in a scale of 1 to 5, and we classified into frequent drivers and rare drivers by combining the first 2 and the last 3 of those Likert scale data. Our results, even though there were no consistent difference in the accuracy of prediction, there was a noticeable difference in how confident they were with the use of gaze data. Frequent drivers were considerably more confident than rare drivers here. And the difference for the no gaze condition was not so much different between the two set of drivers. Okay, so the ability to anticipate your collaboration partner's next move can be extremely advantageous in a collaboration setting. So it could make the collaboration more proactive, so you could convey more information even before there is a need for it. And it could also improve the subjective experience in the collaboration by being in control, by knowing what your partner would do next. And our results suggest that overlaying gaze information in the egocentric view could potentially give that benefit. But then one thing to note is that we did not have an actual collaborative scenario. So our results it theoretically shows the value of having the gaze overlay in the video, and future research should look into if these benefits that we measured is actually available in a real-world collaborative settings, and if yes, how it influences the collaboration. And if it's not available in the collaborative settings, why, and what negates the benefit that we just noticed. there are a couple of other interesting things that we noted. It was also evident from the user comments that there was some learning effect involved. For example, our participants commented that once I saw the previewing video, it was clear how the gaze would behave. So it could indicate that the frequent collaborators could learn to behave the gaze cue better. And also the task-related expertise may enable more confident use of the gaze information. To conclude, I rest my case with this final statement. Our results show the utility of gaze-overlaid egocentric video and encourages further research in real-world collaborative settings. Thank you, and I'll take questions if you have any.
I'll ask one. I was curious because humans can predict where drivers are turning. You can automate that in some way. So maybe like a computer can predict and help you by turning on your turn signal.
Yeah. Well, that's true. But then we picked driving as a representative scenario. But then these look-ahead fixations, they are ubiquitous in many other scenarios as well. So I would speculate that these benefits should also show up in some other real-world settings other than driving.
Mm-hmm. Great. Any questions? All right, let's thank our speaker one more time.